The Higgs mechanism is really very simple in many respects. We have in the universe, everywhere, the potential for particles to exist. These are fields, vacuum fluctuations. The Higgs is among those. And if the temperature of the universe were very high, it would have really no effect, because its effect is very much randomized. But at a certain point, it froze. The Higgs became very well aligned throughout the universe in its internal dimensions. And when that happened, it coupled directly to other particles, giving them mass. It's very much like what the Stoics talked about more than 3,000 years ago. There's something that permeates the entire universe that gives all things substance. And this is exactly what the Higgs particle does, and the Higgs field does, once it's been frozen out in this way that I described. Now, the interesting thing is, unlike perhaps the image you have from the Stoics, that we are some sort of ghostly figures that the Higgs gives substance to, it's really at the particle level that the substance is obtained. And if there were no Higgs mechanism, we would just simply disintegrate. We would not be here. So the latest data are quite interesting. Up until this summer, it was clear that Higgs above a certain mass was ruled out, at least the standard model Higgs. Because in our standard model, we know, as a function of mass, how many Higgs should be produced. There are other models that are more difficult, in a sense, to produce the Higgs, so we wouldn't see them necessarily. But for the standard model, we ruled out quite a large range, and we left really only a very small 25 GeV range between 114 and around 140. In the newest data, we've probed this range now much more, with much greater sensitivity, and it's clear that we cannot yet say something definitive. But there are some tantalizing hints, okay? So 2012 will be the year, in some sense, for us to really understand that region. And if those hints are for real, we may have a strong observation. Of course, there's always the chance they go away. And if they go away, then we know the standard model Higgs is not the right Higgs, but it doesn't mean there's no Higgs. So we have to study and continue to look. It does, however, it will, and it does have significant implications if we don't see anything, for sure. If we find the Higgs at low mass, obviously we'll all be very ecstatic, okay? And it's very exciting in the sense that we've already ruled out, as I said, the range above about 140 times the proton mass. And what that means, in fact, even within the standard model framework, is that there has to be some other physics. We're not sure exactly where, but it already tells us some new physics has to exist. And the lower the Higgs mass is, in fact, the closer we know that new physics must be. So if we discover a Higgs at 120, 125, something like this, it doesn't guarantee we'll find new physics, but it means that there is something more out there. And of course, for us, that's always very exciting, because we're explorers and we want to find new things.